Hello everyone, welcome to my YouTube channel Tech Learn with Data. So today we will discuss about Pyspark optimization. So today we will about performance optimization in Apache Spark. Okay, in in this like Apache Spark is a powerful tool for big data processing. Okay, but as your data grow, you might notice that your Spark jobs are taking longer to complete. This is where performance optimization comes in. Okay, in this video we will explore common performance bottlenecks in Spark and provide practical tips on how to optimize your Spark job. By the end, you will have a clear understanding of how to make your Spark application run faster and more efficiently. Okay, so let's do that. So first thing is that why optimize Spark job? First thing is that reducing processing time. If your jobs is faster means quicker insight, it will give you the faster result. Saving second thing is that saving resource. If you increasing your Spark, if you increase your Spark optimization, that it can also save your cost in case of your memory or in case of your CPU. Okay. Third one is the scaling effectively. Optimized jobs can handle large data set without any crashing. Okay. If your jobs are faster, then it will also handle the large type of the data set like a 1 TB, 2 TB or 100 types of TBs are there. Okay. So for that one that you need to increase your optimization, increase the performance for your Spark optimization. Okay. There are some common performance bottlenecks in Spark. Okay, so let's discuss one by one. Okay, first thing is that data skew. Okay, let's take a very simple real-time example. Okay, if imaging let's you are going to a hotel or restaurant. Okay, and you give some order. Okay, most of the things that order are coming quickly, but some of times of the order does not come quickly. Okay, quickly, so it will take some time. That's the which is also taking so much time. It also impact on your this. Okay, because let's you have some partitions are there. Okay, some of the partition is not taking time, but one partition is taking so much time, so that is the problem. Okay, so problem is that if few partition have significantly more data than others, okay, that is also the causing delay. Taking an example, okay, like if you are analyzing customer transactions, okay, and 90% of the transaction along to one customer, so that 90% transaction is taking so much time only for one customer. Okay, and others are quickly executed. That is the portion of that customer will take much longer to process. Okay, hope you have understood this one scenario. Second one is suppling. Okay, imagine you are moving to a new house and you pack all your furniture into box and load them into a truck. Okay, the truck drive to the new house and you unload the boxes. This process is the time consuming and tiring also. So okay, now if you are first you need to everything box and you need to packaging into your luggage or and everything, and after then whenever you move into the new house that you unbox on that one, that is the time consuming thing. Okay, if you are unboxing or just keep the everything into your truck and just keep the all everything luggage or into your new house, that it will after, so this type of that this will take not so much time. So problem is that suppling involve moving data between nodes which is slow and the resource intensive. Okay, when you talk in terms of the Spark, when you perform a group by operation, Spark needs to move all values with the same key to the same partition. Okay, so moving data between nodes during operation like group by or join, it will take time, and suppling is expensive and can slow down your job. Okay, third one is the garbage collection. Okay, imagine your room is cluttered with toys, clothes, and books. Every time you want to do something, you have to stop and clean up the mess. This is your constant cleaning slow you down. Okay, so problem is that if you're frequently garbage collection code slow down your code. If you are frequently garbage collection on your Spark job, it will take so much time. Every time you are starting the job, you are cleaning first you are cleaning everything, and you can also start the job, so it will take time. So if your Spark job create any short living object, the JVM main frequently posed to perform garbage collection. Okay, so frequently garbage collection goes in your job execution. Second one is that this is often due to excessive memory usage. So avoid garbage collection in your Spark job. Next one is the input output bottlenecks. Okay, like imagine you are trying to watch a movie, but your internet connection is very slow. So it will take time to your buffering of your video. So and you can't enjoy it for that one because your internet connection is very low. The speed is very low. That is taking so much time. So problem is that if you are reading or writing any data to from disk or network, that can be slow. Okay. So reading a large data set from a slow disk or writing intermediate result to a network file system, that can slow down on your job. Okay, so there are two things are there: reading, writing data from this, that can be slow. If you are taking to if you are taking the network, or that network is very slow, that it will also impact on your performance. Second one is thing, this is especially true for large data set. Okay, if your data set is very large, like a 3 TB or 2 TB, 3 TB, or GB, also like the 100 of GB or the 200 of GB, so it will take so much time, and it can cause your efficiency or performance. The last one is that is the inefficient code. Let's imagine you are packing for a weekend trip, and instead of packing only what you need, you bring your entire wardrobe. Okay, let's assume you need to write only 2 or 3 lines of the code, but whatever you done that, for the instead of 2 or 3 lines code, you are writing every function or everything, and you are executing every function each and every time. So that times that is very difficult. That can also be caused to increase your slowness. Okay, and that's why it is so. Avoid the inefficient code in your Spark execution. Okay, because it will take so much time. Okay, so problem is that if you poorly written transformation or actions leads to unnecessary computation. Okay, if you are using any unused functions in your code, okay, and you are executing each and every time, execute the function on each and every time. Okay, so it will take to execute for the unnecessary computation, and it will take some memory, it will take the process CPU, that it will take slow your process. So example is that if you are using collect to bring our data to drive program, that it will enhance only a subset is needed. Okay, second one is that poorly written transformation or action can lead to unnecessary computation. So these types of the common performance bottlenecks in your Spark. So avoid these one. Okay. So let's take how can one let's take that how can we increase to optimize Spark jobs. Okay. First, that one is the use the right level of parallelism. Okay. If we talk about the parallelism, so what is the parallelism? Parallelism refers to the number of tasks that can be executed simultaneously. Okay, in Spark, this is controlled by the number of partition in your RDD data frame. Okay, so first thing is that how to optimize this one. That means you need to increase the partition. Okay, let's example you have a 12 months, January to December. Okay, and if you need to computation or execute the data only for the December, what will you do? First thing, if you don't do the partition, that you need to execute whole types of the data from themes January to December. But if you partition from January to December, divide by the month, that at that time you can, if you will get only for the December month. Okay, and you need to execute or computation only for the December month to execute further. So this is that you need to increase the partition. Second one thing, avoid also too many partition. Okay, let's assume you are using the week. If you are partition from month to week, okay, that it also it's also decrease the performance. Okay, but it will also benefit that if you are if you are only execution for the weekly basis, it will be benefit. But if you are using for the monthly basis, it can also cause the issue. So avoid too many partition for this time. Second one is the minimize shuffling. Okay, so shuffling occurs when data is redistributed across nodes, such as during group by or join operations. So for the optimize, you need to use reduce by key, okay, instead of group by key. Okay, that one is the common thing that you need to use that one. Second one is use the broadcast small data set. Okay, use broadcast to send small data set to all nodes. That you need to use the smart broadcast join to perform, like that you are using the multiple types of data frame. Okay, and if you have the small data set, a large data set, that you need to use the broadcast join. Third one is the optimized memory usage. So why is memory important? Actually, Spark perform best when data fits into the memory. Okay, if the out of memory, it will cause the issue for the performance. Okay, excessive memory usage can lead to garbage collection pause. Okay, so what will you do? You need to cache wisely. You need to cache the data into your cache memory and then perform according to the perform. Okay. Second one is thing a use efficient data format, that you need to use the columnar format like Parquet or RC for the storage. Okay, that one is the thing one. Fourth one is the avoid data skew. I have told you that data skew are that when some partition have significantly more data than others, that will cause the delay. Okay, if like I have already told you in this earlier that if only one partition for also taking the 90%, 90% transaction are taking only for one customer. Okay, it will cause the issue. So avoid the data skew. Okay, how to optimize? First one thing is the sorting. Okay, add a random prefix to key to distributed data eventually. Second one is the repartition. Okay, that use repartition to event distributed data. Okay, last one is the tune Spark configuration. So what is Spark configuration? Spark provide many configuration options that to fine tune performance. That is, this is also the increase executor memory, that you can also increase the memory for the execute. Okay, second one is adjust shuffling partition. Increase the number of shuffle partition. That okay, like if you are need to like there is a one thing like the spark.sql.shuffle partition, that you can also set 200 or 1000 is there. Okay, so let's take some example in the Pyspark code. So open the Visual Studio and let's try to do code. Okay, so let's initialize the Spark context. Okay, from Pyspark import Spark context. S is equal to Spark context local simple app. Okay, just a simple this one. Let's take application name is word count example. Word count. Okay, it's like this one. So it has been initialized. Take this one. Oh, read the file sc.txt file data.txt. Simple. Okay, and take the word count. That rdt.flatmap lambda line dot split. Okay, and dot that we need to count the for the word. Okay, that's why we need to lambda word one by one, that we need to count to the words. Okay, that needs to group by k and map values, and we need to length. Okay, Now what we will do, words count dot collect. Let's see how much time it will take. So it has been taken around 4.6 seconds. Okay, this one. Now if we need to optimize this one code, so what we can do, we can also do one thing that I have already told you, that we need to replace group by key with reduce by key, and also we can also keep word counts into cache, okay, into cache memory, and then execute the word count collect function. Okay, let's do check and what we can be the impact on this one. Okay, for this one, that we have this one code, simple, take this one. Okay, and for here that we can also reduce by key. Okay, and we can use here lambda x comma y. Okay, x plus y. Okay, it also uses a reduce by key instead of group by key. Okay, and just remove this one. Check. And what we will do, before collect that, we will do a word count dot cache, simple cache function. Now try to execute this one. So it has been taken 2.8 seconds. Okay, that we are using reduce by key and this one. Okay, first one is taking 4.6, now it is taking 2.6. So this data have come into the cache memory. Okay, so next one, what we will do, we will just execute word count dot collects. Okay, because we have executed this one. Check into the cache memory, that come check into here, and then execute. It has been executed only just 0.1 second. Okay, so now you have checked that how can we increase the performance, that we can some optimize your that your code also, that you can also perform to just replace group by key to with the reduce by key. Just you need to use the cache memory, you need to use the partitions as well. Okay, so this one the from this optimization technique, that you can also you reduce your execution time, you can also minimize your resource usage, and you can also improve your cluster efficiency. Okay, so thanks for watching. If you found this video helpful, don't forget to give it a thumbs up and subscribe to the channel. Okay, for more content. See you in the next video. Thank you.